How does SpaceX iterate Starship so ridiculously fast? This is the biggest and most powerful rocket ever built, yet SpaceX flies it, learns from it, redesigns it, and rolls out a new version at a pace we've never really seen in the rocket industry. We're already on version 3, and each generation has introduced major design changes instead of just a few minor tweaks. So how can SpaceX keep upgrading a 120-meter tall rocket like it's getting a software update? And more importantly, why are they in such a hurry? Let's find out. SpaceX has become the most successful commercial launch company in history. They've now completed more than 600 launches, with over 500 of them using reusable boosters. That's a number that would have sounded completely ridiculous just 10 years ago. A big reason for that success is that SpaceX doesn't treat rockets the way the rest of the industry does. They treat them more like smartphones. Seriously. Every new Starship or Falcon isn't supposed to be the perfect version. It's more like downloading the latest software update. Version 1 has bugs, version 2 fixes some of them, version 3 finally makes everything work. Hopefully. It's a strange way to build rockets, but somehow it works. Because if you look at the rest of the space industry, development usually moves at, let's just say, government paperwork speed. NASA's Space Launch System, or SLS, spent 11 years in development before finally launching in 2022. And that's despite recycling engines and major hardware from the space shuttle. Europe's Ariane 6 wasn't much faster either, taking roughly a decade before its first flight. Meanwhile, SpaceX went from a tiny Starship prototype hopping a few meters off the ground in 2019 to launching fully stacked vehicles into orbit and literally catching giant boosters out of mid-air just a few years later. That's not normal. In fact, if another company announced they planned to pull that off on the same timeline, most people would have assumed they accidentally added an extra zero or forgot how calendars work. So how do they do it? Well, unlike most aerospace companies that spend years trying to make sure the first launch goes perfectly, SpaceX is perfectly willing to launch a rocket that might explode. Not because explosions are part of the marketing strategy, although they certainly get people's attention, but because every failure produces an enormous amount of real-world data. Instead of treating a failed launch as the end of the project, they treat it like a very expensive engineering report. They figure out what went wrong, redesign the hardware, build another vehicle, and try again. Then they repeat that cycle over and over until the rocket is good enough for regular service. Of course, saying, just build rockets faster, is kind of like saying, just become a billionaire. It sounds simple until you actually try it. There are several key ingredients that you must obtain to make this rapid iteration approach possible. The first requirement is actually pretty simple. You need to subscribe to the channel. I'm kidding. Although, to be fair, you can probably hit that button faster than SpaceX can build a Starship, so you might as well. Anyway, the real first requirement for rapid iteration is being absolutely loaded with hardware. Because this whole build it, fly it, blow it up, learn from it, then build another one next week strategy sounds great, right up until you realize rockets cost millions of dollars each. Traditional aerospace companies usually can't afford to treat prototypes like disposable engineering experiments. Every rocket is expected to work because nobody wants to explain to the people writing the checks why they just turned several $100 million into an unusually expensive fireworks show. SpaceX, on the other hand, has a few advantages. For starters, Falcon 9 launches bring in a steady stream of commercial revenue. Then there's Starlink, which has become a massive business in its own right, generating billions while also helping fund the company's bigger ambitions. Investors are also much more willing to pour money into SpaceX because, at this point, they've earned a reputation for actually delivering. And if more capital is needed, Elon Musk still owns a large share of the company and has repeatedly shown he can raise enormous amounts of funding. That doesn't mean the government isn't involved, though. SpaceX has also secured billions of dollars in U.S. government contracts, including NASA's multi-billion-dollar Human Landing System contract to develop a lunar version of Starship for the Artemis missions. When you put all of that together, SpaceX ends up in a very different position from most rocket companies. Instead of constantly asking, can we afford to build another prototype? They can ask, would building another prototype help us learn faster? Of course, none of this means SpaceX is happy to throw away millions of dollars every time a prototype explodes. If your development strategy is build, test, break, repeat, then step one is making sure each rocket doesn't cost a fortune in the first place. And that's exactly why switching to stainless steel turned out to be such a big deal. Originally, Starship was supposed to be built from carbon fiber. On paper, that sounded like the obvious choice. It's lightweight, incredibly strong, and used throughout the aerospace industry. The problem is, it's also incredibly expensive. Carbon fiber can cost around $135 per kilogram, and that's before you account for all the material wasted during manufacturing. Stainless steel, meanwhile, costs closer to $3 per kilogram. That's the difference between crying every time a prototype explodes and simply grabbing a clipboard, writing down what went wrong, and starting the next one. Cheaper rockets make rapid testing financially possible. But cost wasn't the only advantage. Starship has to survive two completely opposite environments. One minute it's holding propellants chilled to cryogenic temperatures, and the next it's screaming back through the atmosphere while parts of the vehicle are heated to thousands of degrees. Stainless steel handles that enormous temperature range surprisingly well. Of course, that doesn't mean stainless steel alone is enough to survive re-entry. Starship still relies on thousands of ceramic heat shield tiles covering the windward side of the vehicle. Those tiles absorb the brutal heating during re-entry, while the steel structure underneath provides the strength needed for the rest of the mission. So the switch to stainless steel wasn't about eliminating thermal protection. It was about choosing a material that was both practical to manufacture and inexpensive enough to support rapid testing. Just as importantly, stainless steel made Starship much easier to build. Instead of relying on enormous factories filled with specialized tooling like many traditional aerospace programs, SpaceX assembled early Starships from giant rolled steel rings that were welded together into larger sections before being stacked into a complete rocket. Cranes lifted the sections into place, welders joined them together, and much of the work happened outdoors in Boca Chica. Looking back at photos from 2019 and 2020, the production site honestly looked more like a shipyard than the birthplace of the world's most ambitious rocket. Former SpaceX upper stage production lead Tim Barry once explained the philosophy that drives the company's incredibly fast pace of development. Speaking at the 2024 American Institute of Aeronautics and Astronautics Aviation Forum, Barry described a process that's drilled into every engineer at SpaceX. You're constantly going back and finding opportunities to challenge your requirements, deleting more parts, simplifying, optimizing, going faster, and then finally looking for opportunities to automate, but only after you've boiled the process down to its simplest form. As Starship matured, SpaceX gradually moved away from the early people welding rings outside approach and introduced much more automation into the production process. Welding is still a major part of construction today, but the manufacturing system has become far more organized and efficient than it was during those early prototype days. The giant steel rings can be manufactured in parallel before being assembled into complete sections. The 33 Raptor engines are produced on their own dedicated production line, allowing engine manufacturing to continue independently of final vehicle assembly. Even the heat shield was designed with production in mind. Unlike the Space Shuttle, whose thousands of uniquely shaped tiles made maintenance painfully slow and expensive, Starship uses a much smaller variety of tile shapes, making them far easier to manufacture, install, and replace. None of these ideas are especially revolutionary on their own. The real innovation is combining them into a manufacturing system that treats rockets less like handcrafted prototypes and more like products rolling down an assembly line. Once you can build hardware almost as fast as your engineers can improve it, rapid iteration can truly become a genuine competitive advantage. So, just how rapid is rapid iteration? Well, imagine you're building a traditional rocket. You spend years designing it, then even more years analyzing every little detail, holding review after review, making endless revisions, and only once everyone is convinced it's ready do you finally build and launch the thing. If it works, great. If it doesn't, well, That's a very expensive problem because you've just spent the better part of a decade getting to that point. SpaceX does almost the exact opposite. Instead of trying to make the first rocket perfect, they build one, fly it, see what breaks, learn from the data, and immediately start building the next version. The goal isn't to avoid failure at all costs. The goal is to fail early, fail cheaply, and make sure each failure teaches you something useful. That's why nearly every Starship prototype has been different from the one before it. You can actually watch the rocket evolve in real time. Back in the early days, SpaceX wasn't even trying to reach orbit. They built a series of small hopper vehicles whose only job was to prove the basics. Could Starship lift off? Could it hover? Could it land under its own power? Those tests may not have looked particularly exciting compared to today's launches, but they established the foundation for everything that followed. Then came the full-sized prototypes. SN8 was the first Starship to perform the dramatic belly flop maneuver, falling sideways through the atmosphere before attempting to rotate upright for landing. The landing didn't exactly go according to plan. It exploded, but the important part was that the maneuver itself actually worked. Instead of spending years redesigning the vehicle, SpaceX simply built another one, then another. SN9, SN10, and SN11 each incorporated fixes, design changes, and new hardware based on everything learned from the previous flight. Every prototype solved some problems while revealing completely new ones, which was exactly what the engineers wanted. By the time SN15 rolled out, dozens of improvements had already been folded into the design. This time, Starship completed its flight, landed successfully, and stayed in one piece. It was a huge milestone, not because SN15 was perfect, but because it proved the rapid iteration strategy was actually working. That led to Starship version 2, also known as Block 2. Rather than reinventing the rocket from scratch, it refined what had already been learned from the early integrated flight tests. The vehicle became lighter, more reliable, better at surviving re-entry, and capable of carrying even more performance. Once Block 2 had achieved its major objectives, including successful payload deployments, controlled splashdowns, and the first experiments with booster reuse, SpaceX was already ready to move on again. On May 22, 2026, Flight 12 introduced version 3 of both Starship and the Super Heavy booster. The new version is taller, more capable, designed around the new Raptor 3 engines, and includes hardware needed for future orbital refueling and docking missions. Perhaps more importantly, it also showed that the constant cycle of testing and improving was paying off. For the first time, Starship made it through atmospheric re-entry without suffering the burn-through issues that had become one of the program's biggest headaches. There was still an engine problem that forced SpaceX to skip the planned in-space relight test, but right in the next flight, the relight issue had already been addressed. But here's the funny part. For a long time, SpaceX's biggest bottleneck wasn't actually building rockets. It was getting permission to launch them. Seriously, the factory was often capable of building new Starships faster than the company could test them. Manufacturing wasn't the limiting factor anymore. The real challenge was waiting for FAA approvals, flying the vehicle, collecting the data, figuring out what went wrong, and then getting permission to fly again. For a company whose entire philosophy is test, learn, improve, those delays can be incredibly frustrating because every day spent waiting is another day you're not collecting new data. The good news for SpaceX is that even this bottleneck may be starting to ease. On July 29th, the Federal Aviation Administration proposed a new rule aimed at speeding up commercial space licensing by removing what it considers unnecessary environmental review requirements for certain rocket launches, spacecraft re-entries, and launch sites. The proposal includes a 30-day public comment period and is part of a broader effort by the Department of Transportation to reduce regulations that it says are slowing American innovation. Now, before anyone imagines rockets launching every afternoon with no oversight, that's not what's happening. The FAA would still be responsible for ensuring launches don't threaten public safety, national security, or U.S. foreign policy. The idea isn't to eliminate safety reviews, it's to streamline parts of the licensing process that the agency believes no longer add much value. Whether the proposal is approved, and whether it actually makes a noticeable difference remains to be seen. But if SpaceX can build starships faster and get them into the air more quickly, then the company's rapid iteration philosophy could become even faster than it already is. So that leaves us with one final question. Why the rush? Why is SpaceX so obsessed with moving at this almost uncomfortable pace? Some people would say it's because of competition, and they're not entirely wrong. History has shown that competition is a fantastic motivator. During the Apollo era, the United States and the Soviet Union pushed each other to achieve what many thought was impossible. And today, companies like Blue Origin are also trying to build the next generation of reusable rockets. Has Blue Origin dramatically sped up SpaceX's development? That's debatable. But in general, having someone else chasing the same goal usually makes everyone move a little faster. Nobody wants to be the company that shows up to the finish line after everyone has already gone home. But I don't think that's the real reason. In fact, SpaceX has been pretty open about it for years. If you listen to Elon Musk, the thing he worries about most isn't running out of money, it isn't losing customers, and it isn't another company building a bigger rocket, it's running out of time. From the day SpaceX was founded, the company's long-term mission hasn't just been launching satellites or carrying astronauts to orbit. Those are important businesses, but they're also stepping stones towards something much bigger. The real goal is making humanity a multiplanetary species. More specifically, Musk has repeatedly said he wants to build a self-sustaining city on Mars, and he wants to see it happen during his lifetime. Now, whether you think that's inspiring, wildly optimistic, or sounds like the plot of a sci-fi movie, that's a separate conversation. But if that's genuinely your goal, then suddenly the urgency starts to make sense. It took SpaceX nearly 20 years just to go from a tiny startup with one small rocket to regularly flying astronauts into space. Getting people to Mars is an entirely different level of difficulty. Then you have to keep them alive. Then you have to build a settlement. Then you have to turn that settlement into a city that can survive without constant help from Earth. That's not something you knock out over a long weekend. Every year you save today is another year you can spend solving the next problem tomorrow. And that's why SpaceX moves the way it does. They're not racing because the calendar says they have to. They're racing because their destination is so incredibly far away that moving slowly simply isn't an option. Whether they ultimately succeed or not is still an open question. But if they ever do put a self-sustaining city on Mars, it probably won't happen because they built the perfect rocket on the first try. It'll happen because they built hundreds of rockets, learned something from every single one of them, and never stopped improving.